Welcome to the northern part of the Absaroka Mountains. Hi, I'm George Miller from the Buffalo Bill Center of the West, and today we're talking about the northern Absaroka in Wyoming and Montana. And in the northern Absaroka is actually Montana's highest peak, which is 12,799 feet, or about 3,900 meters, and that's Granite Peak. Well, the southern part of the Absarokas have very high peaks, but the northern part has a lot more uplift, and we'll talk about the geologic structures here as we go through. We're looking down toward Sunlight Basin, and Sunlight Basin was a center of volcanic activity from about 49 million to 48 million years ago, and there were sort of three different stages. The last stage was more basaltic, and it has some solidified pieces that we'll be able to see in this next clip. We're going to take a look at White Mountain, and here it is. And if you look at those black streaks coming up through the white Paleozoic limestone, we can see intrusive dikes and sills. Sills are lateral intrusions of lava where they've solidified. And then you can see the volcanic material on top. And that volcanic material looks a lot like what we saw last week in the southern part of the Absaroka Mountains, those massive volcanic eruptions. Well, Sunlight is very interesting. And as we go up the valley toward Yellowstone in the Clark's Fork Valley, we can see the underlying Pilgrim limestone. So these limestones were deposited many, many millions of years earlier, hundreds of years, millions of years earlier than the volcanic material. And if you look at that volcanic material on top, you see the spires that have eroded away in that volcanic material, much like the North Fork. Well, one other big mover here in this area is glaciation. So glaciers start when there's more snow than melts. So if you get more snow in a year than melts in a year, that's the beginning of a glacier. Now, most of our area has permanent snowfields, not glaciers. So there's snowfields that last all year long, but they don't move, and that's the difference. Permanent snowfield doesn't move down the hill like a glacier does. Glaciers build up enough ice that they can start to actually move down the hill, and they scour the landscape. Now, something like Index Peak here and Pilot Peak here were actually sculpted by glaciers. They were surrounded by glaciers, but not overtopped by glaciers. So the tops were never eroded away, but all around them were, and they make these beautiful, beautiful mountains. Another interesting piece of glaciation is in the Sunlight Basin that we looked at earlier. And Sunlight is this huge glacial valley, and it actually was dammed. So Sunlight Creek was dammed and built a huge lake behind the glacier. And then as the lake would melt periodically, it would flood the lower lying areas. Well, also eroding this valley after the glaciers left was Sunlight Creek. So Sunlight Creek is flowing through this valley, and here it is, still eroding. And that's the big erosive forces in our areas, glaciers and rivers and streams. So rivers and streams carry off a huge amount of material every year. Now, inhibiting that erosion is vegetation. So you can see here in this little tiny stream that the vegetation that's growing here is holding on to the land, holding on to the structures. And look at this old tree, holding on for its dear life, putting those roots down into the earth and holding rocks together and soil together. So the erosive forces are counteracted by vegetation. It's spring here when I'm filming this, and runoff is at high flow. So we see these little streams that would dry up in the summer. And a stream like this has moved boulders down into its bed. A beautiful sight. thank you for being with me today here in the Northern Absarokas. For the Buffalo Bill Center of the West, I'm George Miller. Please like and subscribe if you're enjoying this series on YouTube. Thanks and goodbye.